Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 9 Matrices, Multiplication of Matrices. We have studied the concepts about matrices and also we have solved questions from the multiplication of matrices with a scalar. We will be understanding the concepts and solving more questions from exercise 9C. Are you all ready? Let's start. Multiplication of matrices. We have studied the addition and subtraction of matrices. While performing the addition and subtraction of matrices, there was the first condition which we followed. We have to check the order of the matrices. Only if both the matrices considered are of the same order, they can be added or subtracted. Now, when it comes to multiplication, let us check what the condition is. Two matrices A and B can be multiplied together to get the product matrix AB if and only if the number of columns in the first matrix A is equal to the number of rows in the second matrix B. We will take an example. Here we have two matrices, matrix A and matrix B. A is equal to 2, 4, 3, 5 and B is equal to 1, 3, 6, 2. Now, to check if we can perform the multiplication, we have to get an idea about the number of rows and number of columns of both the matrices. Number of rows by number of columns, we call it the order of matrix. We have to get an idea about the order of the matrix. Check the first matrix. What is the order of this matrix? Here we have two rows, R1, R2. We have two columns as well, C1, C2. Two rows, two columns. Number of rows by number of columns gives us the order of the matrix. This is a 2 by 2 matrix. Now check the second one. Here again we have two rows. First row, second row. First column, second column. We have two columns. Then what is the order of this matrix? This is again a 2 by 2 matrix. Now what is the condition? Number of columns in the first matrix should be equal to number of rows in the second matrix. Here what is the number of columns in first matrix? 2. Number of columns in the first matrix is 2. Number of rows in the second matrix. This is again 2. Which means number of columns in first matrix is equal to number of columns in second matrix. In this case we can perform the matrix multiplication. Yes? Now we will take another example. We have a matrix C is equal to 1, 3, 5, 2 and matrix D is equal to 5, 3. Okay. What is the order of this matrix? Here we have two rows, two columns. This is a 2 by 2 matrix. What about this matrix D? Here, what is the number of row? Here there is only a single row, which means 1 by number of columns. We have two columns, C1, C2. 1 by 2. Okay. Then can we perform the matrix multiplication? Check if we can perform the matrix multiplication in this case. Here what is the number of columns in the first matrix? We have two columns. Number of rows in the second matrix? Only a single row. This is a row matrix. Can we perform? No, right? Because number of columns not equal to number of columns in first matrix not equal to number of rows in second matrix. Therefore, we cannot perform the matrix multiplication. In this case, that is, when you take a 2 by 2 matrix and a 1 by 2 matrix, we cannot perform matrix multiplication. Next, another example, we are taking a matrix E is equal to 5, 9, 3, 2. Matrix F is equal to 5, 2. Can we perform this matrix multiplication? Check. Here we have a 2 by 2 matrix. This is a 2 by 2 matrix. 2 rows, 2 columns. What about this? here the number of rows is 2 and the number of column is 1. This is a 2 by 1 matrix. 1 by 2 matrix and 2 by 1 matrix. Find the difference. Here 1 by 2 matrix, this is a row matrix. 2 by 1 matrix, this is a column matrix. Now when you check the number of columns in the first matrix and number of rows in the second matrix, we get equal, right? Number of columns in first matrix is equal to number of rows in the second matrix. In this case again we can perform matrix multiplication. Got it? Therefore we understood that when a 2 by 2 matrix and another 2 by 2 matrix is taken, we can perform the matrix multiplication. In general, if you are taking a matrix A, which is an m by n matrix, and a matrix B, which is an n by p matrix. Here we have to take this condition, that is the number of columns in the first matrix should be equal to number of rows in the second matrix. That's why we have represented the same letter, same variable for the columns and rows. Okay, and this is P. P is used to represent the number of columns in the second matrix. M represents the number of rows in the first matrix. In that case, when you perform the matrix multiplication, you will get a new matrix which is of order M by P. That is number of rows in the first matrix and number of columns of the second matrix. Got it? Let's perform this. To understand, we have A matrix 2, 4, 3, 5 and B matrix 1, 3, 6, 2. We are going to multiply. We will perform the multiplication. We got the order of this matrix. Here we have the number of rows is equal to 2 and number of columns in the second matrix 2. Therefore, order of the product matrix AB will be equal to 2 by 2. Okay, we got the order. Now we have to fill the elements. Let's see how we can fill these elements. Here we will be having 4 elements. This is a 2 by 2 matrix. In 2 by 2 matrix, there will be 2 rows and 2 columns, which means we will be having a 4 elements in this case. First element, let's see how to find the first element. First element. To get the first element, we have to consider first row of the first matrix and first column of the second matrix. We are going to multiply them. Here again, take the first element of first row of first matrix and multiply with the first element of the first column of second matrix. That is 2 into 1. 2 into 1. Okay. Next, we have to consider the second element of the first row of first matrix and the second element of the first column of the second matrix. Here we have 6. Multiply them. 4 into 6. Next, we will be adding these two. When you add these two, you will be getting the first element. Here, what is the first element? 2 into 1. 2 plus 4 into 6. 24. Therefore, the first element is 2 plus 24, which is equal to 26. Got it? Understood? 26 is the first element. Now, to get the second element. Second element. Here, we are going to find the second element. We have to consider first row of the first matrix and the second column of second matrix. Again, similar multiplication we are going to perform. Here we have considered the first row of first matrix and the second column of second matrix. Multiply the first elements. Here 2 is the first element. Here 3 is the first element. 2 into 3. 2 into 3. Then consider the second elements of this first row and the second column. 4 and 2. 4 into 2. 4 into 2. Add them. Okay. 2 into 3, 6 plus 4 into 2, 8. 6 plus 8, 14. Okay. 14 is the second element. Now, the third element. To get the third element, we have to consider second row of the first matrix and the first column of second matrix. To get this element, third element, we are considering second row of first matrix and the first column of the second matrix. Here, check the first elements. Here it is 3 and here it is 1. 3 into 1. 3 into 1. Then second element of second row, that is 5. Second element of first column, which is 6. 5 into 6. 5 into 6. You have to add them. 3 into 1, 3 plus 5 into 6, 30, which is equal to 3 plus 30, 33. So 33 is our third element. Now find the fourth element. How much will you get? Fourth element, we will consider the second row of first matrix and the second column of the second matrix. Check the first elements. Here we have 3, here we have 3. 3 into 3. Fourth element, 3 into 3 plus. Next, second elements, here we have 5, here we have 2. 5 into 2. 5 into 2. What do we get? 3 into 3, 9 plus 5 into 2, 10. 9 plus 10, which is 19. So this is how you can perform the matrix multiplication. Got it? First check the order and confirm if the matrix multiplication can be performed. After that, this is how you will find the elements of the matrix. Product matrix. Got it? Understood? For the first element, you have to consider first row of first matrix and the first column of second matrix. To get the second element, we have to consider first row of first matrix, second column of second matrix. Third element, you will be getting with the second row of first matrix and the first column of second matrix. And the fourth element, second row of first matrix and the second column of second matrix. Okay? We understood how to do matrix multiplication. Let us take an example. Here, if A is equal to minus 2, 3, 4, 1 and B is equal to 1, 2, 3, 5, find AB, BA. Let's see if AB and BA are same. We know if you are taking two numbers, 2 into 3 and 3 into 2, they are same. Let us see, is it applicable in the case of matrices? Okay, first we will find AB. We have A is equal to minus 2, 3, 4, 1 and B is equal to 1, 2, 3, 5. AB. What is the order of AB? First we have to find the order of AB. A is a 2 by 2 matrix, 2 rows and 2 columns. What about B? B is again a 2 by 2 matrix, 2 rows and 2 columns. Okay, here M by N, N by P. Then the product matrix will be of the order M by P. Yes, product matrix will be of the order M by P. Here M is 2 and P is also 2. This will be a 2 by 2 matrix. Okay, now we will find the elements of these matrices. To get the first element, what should we consider? We have to consider first row of first matrix and the first column of second matrix. Here we have minus 2 as the first element. Here we have 1 as the first element. Minus 2 into 1 plus second elements. Second element of first row, second element of first column. 3 into 3. 3 into 3. Okay. Now to get the second element, we have to consider first row and the second column. First row of first matrix, second column of the second matrix. Minus 2 into 2. These are the first elements. Minus 2 into 2 plus 3 into 5. Second elements. 3 into 5. Okay. Now to get the third element, we have to consider second row and the first column. Here the second row contains 4 and 1. Here we have 1 and 3 in the first column. Considering the first elements, 4 into 1. 4 into 1 plus 1 into 3. Second elements. 1 into 3. Now to get the fourth, we have to take the second row and the second column. Second row of first matrix and the second column of the second matrix. 4 into 2. First elements 4 into 2 plus 1 into 5. Okay. Now, we'll perform the multiplication and the addition. Minus 2 into 1 is minus 2 plus 3 into 3, 9. Here, minus 2 into 2 is minus 4 plus 3 into 5, 15. Next, 4 into 1, 4 plus 3 into 1, 3. Next, 4 into 2, 8 plus 1 into 5, 5. Then what are the elements? We'll be getting minus 2 plus 9, 7. Minus 4 plus 15, 11. 4 plus 3, 7 again. 8 plus 5, 13. So we got AB. AB is a 2 by 2 matrix with elements 7, 11, 7, 13. Now we'll find BA, which is our second part of the question. To find BA, we have to multiply B and A. We have to take B first. What is B here? 1, 2, 3, 5 and A is minus 2, 3, 4, 1. When you are finding BA, place B first. Only after that you have to place A. Same procedures. Here again we have 2 by 2, 2 by 2 matrices. Product matrix also will be a 2 by 2 matrix. Now filling the elements. First element 1 into minus 2. First row, first column. 1 into minus 2, minus 2. Then 2 into 4. 2 into 4 is 8 plus equal to. We'll again be getting a 2 by 2 matrix. Here we have a 2 by 2 matrix. This is also a 2 by 2 matrix and the product matrix will be a 2 by 2 matrix. Now we'll find the elements of this matrix. Here the first element. To get the first element, we have to consider first row of first matrix and the first column of second matrix. 1 into minus 2, which is minus 2. 2 into 4, that is 8 plus 8. Next, second element, first row, second column. 1 into 3, 3. 2 into 1, 2 plus 2. Next, third element, we have to consider second row of first matrix and the first column of second matrix. 3 into minus 2, minus 6. 5 into 4, that is 20 plus 20. Okay. Now the fourth one, second row, second column. 3 into 3, 9 plus 5 into 1, 5. Adding this, we will be getting the elements of BA, product matrix BA. Minus 2 plus 8 is 6. 3 plus 2 is 5. Minus 6 plus 20. Minus 6 plus 20 is 14. 9 plus 5, that is again 40. This is what BA is. Now compare AB and BA. Are they same? AB is the elements. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. Order, they are of the same order. But matrices will be equal only when the orders are equal and also the corresponding elements are equal. Here we have 7 and here the first element is 6. This is 11, this is 5. Here 7, 14, 13, 14. Elements are not equal, which means AB is not equal to BA. We can say that matrix multiplication is not commutative. If AB is equal to BA, that is when you reverse the matrices and perform the multiplication, if you are getting them equal, we can say that matrix multiplication is commutative. But from this we can conclude that matrix multiplication is not commutative. Not commutative. Okay. With this example, we can make this conclusion: matrix multiplication is not commutative. Clear? Next, another example. Here we have matrix A is equal to 1, 3, 2, 4, B is equal to 1, 2, 4, 3 and C is equal to 4, 3, 1, 2. Find AB into C. First we have to find AB, then multiply with matrix C. Second, A into BC. Third, we have to find is A into BC equal to AB into C. We have to prove if this associative property is obeyed by matrix multiplication. This is a condition for associative property. Yes. We have to prove if matrix multiplication is associative or not. If AB into C is equal to A into BC, then matrix multiplication is associative. We have got that matrix multiplication is not commutative. We will check if matrix multiplication is associative or not. First, we have to find AB into C. Let's find what AB is. AB is equal to matrix A 1, 3, 2, 4 into 1, 2, 4, 3. Perform the multiplication. Now we are experts, right? Yes. This is a 2 by 2 matrix. This is a 2 by 2 matrix. We can perform the matrix multiplication. And the product matrix will also be a 2 by 2 matrix. Number of rows in the first matrix by number of columns in the second matrix. Now to get the elements. First element, we have to take first row, first column. 1 into 1, 1 plus 3 into 4. 3 into 4 is 12. 12 plus 1, 13. Okay. Next, first row, second column. To get the second element, we have to take first row and the second column. First elements, 1 into 2, 2 plus 3 into 3, 9. 2 plus 9, which is 11. We got the second element. Next, third element, considering the second row and the first column of second matrix. 2 into 1, 2 plus 4 into 4, 16. 2 plus 16, 18. Next one, second row, second column. 2 into 2, 4. 4 into 3, 12, which is 16. We got AB. Next we have to find AB into C. This is AB, 13, 11, 18, 16 multiplied with C. Here we have C. 4, 3, 1, 2. Again we will be getting a 2 by 2 matrix, right? This is a 2 by 2 matrix. This is also a 2 by 2 matrix. 2 by 2 matrix and 2 by 2 matrix, when multiplied, the product matrix should be a 2 by 2 matrix. What are the elements? 13 into 4. 13 into 4 will be getting 52. Next, plus 11 into 1. 11 into 1 is 11. To get the second element, considering first row, second column. 13 into 3. 13 into 3 is 39. 39, 11 into 2, 22. 39 plus 22. Next element, we have to take second row, first column. 18 into 4. What is 18 into 4? We will be getting 72 plus 16 into 1, 16. Next element, second row, second column. 18 into 3, that is 54 plus 16 into 2, 32. Adding this, we will be getting the elements of AB into C. AB into C is equal to 52 plus 11, that is 63. 39 plus 22, which is 61. 72 plus 16, 88. Next, 54 plus 32. 54 plus 30 is 84. 84 plus 2, 86. So, these are the elements of AB into C. Now, you can find A into BC on your own. You have to first find BC, then multiply with A. You can try it. When you multiply find BC and multiply with A, you will again be getting 63, 61, 88, 86. Okay, you will perform, right? You can perform and check this multiplication, which means we can say that AB into C is always equal to A into BC. You have to first find BC and multiply it with A. You will get A into BC. A into BC and AB into C will be equal. You know how to perform multiplication? Yes? You can check this. You will get it clear that AB into C is equal to A into BC, which means matrix multiplication is associative. Matrix multiplication is associative. Clear? Next, we have to discuss the identity matrix for multiplication. For addition, we had an identity matrix. You remember? When a matrix is added to a null matrix, you will be getting the same matrix. So, here identity matrix for multiplication means when a matrix is multiplied with the matrix, you will be getting the same matrix. Yes? Here, let us try with the null matrix. We are taking a matrix A is equal to 2, 3, 1, 2. What is null matrix or zero matrix? With elements, a matrix with elements 0, 0, 0, 0. We are taking an example of 2 by 2 matrix. When you multiply these two matrices, what do we get? A into O. What are the elements? You will be getting a 2 by 2 matrix. Order will be 2 by 2. Now the elements, first element 2 into 0, 0, 3 into 0, 0. First element is 0 plus 0, 0. Next, second element, first row, second column, 2 into 0, 0, 3 into 0, 0. 0 plus 0, again 0. Next, if you are taking the second row, first column to get the third element, 1 into 0, 0, 2 into 0, 0. 0 plus 0 is 0. To get the fourth element, second row, second column, 1 into 0, 0, 2 into 0, 0. 0 plus 0 is again 0. Which means null matrix is not the identity matrix. You should get the same matrix. Only then null matrix can be the identity matrix of multiplication. We know null matrix is the identity matrix for addition. But in case of multiplication, when a null matrix is multiplied with any matrix, the product will be a null matrix itself. We are getting product null matrix. Now let us try with another matrix. Here, taking the same example, I am going to multiply this with identity matrix. 2, 3, 1, 2 into 1, 0, 0, 1. 2, 3, 1, 2 into 1, 0, 0, 1. What do we get? First element. Here again 2 by 2 matrix into 2 by 2 matrix, product matrix will be a 2 by 2 matrix. Okay. First element, we have to consider first row, first column. 2 into 1, 2 plus 3 into 0, 0. Next element, 2 into 0, 0 plus 3 into 1, 3. 0 plus 3. Next element, second row, first column. 1 into 1, 1 plus 2 into 0, 0. Next element, second row, second column. 1 into 0, 0 plus 2 into 1, 2. That is, the elements of AI are first element 2 plus 0, 2. Second, 0 plus 3, 3. 1 plus 0, 1. 0 plus 2, 2. So, these are the elements of product of matrix A and identity matrix. This is same as matrix A. Here we have taken matrix A is equal to 2, 3, 1, 2. That is, a matrix A into identity matrix gives us the same matrix A. Okay? Which means this identity matrix is the identity matrix of multiplication. Identity matrix for multiplication is the identity matrix. Therefore, in matrix multiplication, the unit matrix I, or we will call it identity matrix, is known as the identity matrix for multiplication, since on multiplying any matrix with the identity matrix of the same order, the matrix remains unaltered. Here in this example, we are getting the same matrix A itself. Now, when identity matrix is multiplied with matrix A, we know that matrix multiplication is not commutative. We have proved that. Okay. Here we have a matrix A into identity matrix is the same matrix. Now, let us find identity matrix into A. Are they equal to matrix A? Identity matrix is 1, 0, 0, 1 and matrix A is 2, 3, 1, 2. We will perform the multiplication. 2 by 2 matrix into 2 by 2 matrix, product is a 2 by 2 matrix. To get the first element, considering first row, first column, 1 into 2, 2 plus 0 into 1, 0. Second element, 1 into 3, 3 plus 0 into 2, 0. Third element, second row, first column, 0 into 2, 0 plus 1 into 1, 1. Next element, 0 into 3. We are considering the second row, second column, 0 into 3, 0 plus 1 into 2, 2. Then the elements are 2 plus 0, 2, 3 plus 0, 3, 0 plus 1, 1, 0 plus 2, 2. This is again our matrix A. Yes, this is again equal to our matrix A, which means we can conclude that a matrix A into identity matrix is equal to matrix A, that is equal to identity matrix into matrix A. We can reach at this conclusion. Also, we have shown that a matrix A into a null matrix gives us a null matrix. Okay, clear? Next, example 3, given A is equal to x 3 y 3, if A square is equal to 3i, where I is the identity matrix of order 2, find x and y. This was a question that was asked in board exam 2020. Okay, let's solve this. You know what identity matrix is. What are the elements of a 2 by 2 identity matrix? 1, 0, 0, 1. Correct. So, here we have A is equal to x 3 y 3. Also, A square is equal to 3i. First, we will find A square. What is A square? How to find A square? A square is A into A. Okay. Here we know the matrix A. A into A. What are the elements of A? x3, y3, again x3, y3. Now, both of these are 2 by 2 matrices. Matrix multiplication is possible. What are the elements then? To get the first element, we have to multiply the elements of first row and the elements of first column of second matrix. X into x is x square plus 3 into y, 3y. Next, we have to take the first row and the second column. X into 3 is 3x, 3 into 3 is 9, 3x plus 9. Next element, we have to take the second row and the first column. Y into x, that is xy, 3 into y is 3y plus 3y. Then, second row and the second column. Y into 3, 3y plus 3 into 3 is 9. Now, we got the elements of A square. It is given that A square is equal to 3i. What is 3i? 3 into identity matrix. What are the elements of identity matrix? 1, 0, 0, 1, which is equal to. Then 3i will be equal to 3 into 1, 3, 3 into 0, 0, again 3 into 0, 0, 3 into 1, 3. These are the elements of 3i. We have A square is equal to 3i. What is A square? X square plus 3y, then 3x plus 9, xy plus 3y, 3y plus 9. Okay, This is equal to 3, 0, 0, 3. From this we can find the values of x and y. Here this term, it contains both x and y. If you take these two terms, we will have to solve the linear equations in two variables to get the answer. But we have single variable containing terms. Here we have only x, here we have only y. So we will take this and take the corresponding elements to find the value of x and y. So here we are taking the second element, 3x plus 9 is equal to, here the corresponding element is 0, 0. If 3x plus 9 is equal to 0, then how to find x? 3x will be equal to, taking this plus 9 to the opposite side, it becomes minus 9, and x is equal to minus 9 divided by 3. That is, x is equal to minus 9 by 3 is minus 3. We got the value of x. Similarly, we can find the value of y. We have 3y plus 9. The corresponding element here is 3. 3y plus 9 is equal to 3. Then 3y will be equal to 3 minus 9, or 3y is equal to 3 minus 9 is minus 6. And y is equal to minus 6 divided by 3, y is equal to minus 2. Minus 6 by 3 is minus 2. We got the value of x. X is minus 3 and y is minus 2. Clear? First we found what A square, matrix A square, the elements of A square is. Then we equated it with 3i. 3i means 3003. Clear? Next, example 4. If A is equal to 3051 and B is equal to minus 4210, find A square minus 2AB plus B square. This was a question that was asked for ICSE board exam 2020. We will solve this question. First, we need to separately find A square, 2AB and B square. How to get A square? A square will be equal to matrix A into matrix A. Here what is matrix A? Matrix A is 3051 into 3051. To get the first element, we have to take the first row of first matrix and the first column of second matrix. Here the first element is 3, here it is 3. 3 into 3 plus 0 into 5. To get the second element, 3 into 0, which is 0, plus 0 into 1, 0. To get the third element, 5 into 3 is 15, 1 into 5 is 5. To get the fourth element, taking the second row and the second column of second matrix, we will be getting 5 into 0, 0, 1 into 1, 1. That is 3 into 3, 9 plus 0 into 5, 0. That is equal to 9. Here 0 plus 0, 0. 15 plus 5 is 20. 0 plus 1 is 1. So these are the elements of A square. Now we need to find 2AB. How to get 2AB? First we will find AB and multiply with the scalar 2. 2 into, what are the elements of A? A is 3051. B is minus 4210. We will multiply these matrices. Here the first row contains 3 and 0. First column contains minus 4 and 1. The first element we will put 2 outside, which is a scalar. 3 into minus 4, minus 12. 0 into 1 is 0, plus 0. Next element, 3 into 2, 6. 0 into 0, 0. Next element, 5 into minus 4, minus 20. 1 into 1 is 1, plus 1. Last element, 5 into 2, that is second row of the first matrix and the second column of second matrix. 5 into 2, 10. 1 into 0, 0, plus 0. The elements will be equal to 2 into minus 12 plus 0 is minus 12. 6 plus 0 is 6. minus 20 plus 1 is minus 19. 10 plus 0 is 10. Okay. Now we have to multiply each element with the scalar 2. Then we will be getting 2ab is equal to 2 into minus 12 is minus 24. 2 into 6. 2 into 6 is 12. 2 into minus 19, which is minus 38. Then 2 into 10, 20. We got the elements of 2ab. We got a square. A square is equal to 9021 and 2ab. 2ab is minus 24, 12, minus 38 and 20. We need to find b square. B square is equal to b into b. Minus 4210 into minus 4210. Multiply the elements, first row and the first column. We will be getting minus 4 into minus 4 is plus 16. 2 into 1 is 2 plus 2. To get the second element, first row and the second column. Minus 4 into 2 is minus 8. 2 into 0, 0 plus 0. Next element, second row of the first matrix, first column of the second matrix. 1 into minus 4 is minus 4, 0 into 1, 0 plus 0. To get the last element, second row of the first matrix, second column of the second matrix. 1 into 2, 2 plus 0 into 0, 0. Then what are the elements? 16 plus 2, 18, minus 8 plus 0, minus 8, minus 4 plus 0, minus 4, 2 plus 0 is 2. We got b square. Okay, we have a square is equal to 9021. 2ab. 2ab is equal to minus 24, 12, minus 38, 20. We will find a square minus 2ab plus b square. A square minus 2ab plus b square is equal to, what is a square? We have 9, 0, 20 and 1. Next, minus 2ab. Minus 2ab. 2ab is minus 24, then 12, minus 38 and 20 plus b square. What is b square? 18 minus 8 minus 4, 2. 18 minus 8 minus 4, 2. Next step, we will add this to get the first element. We will take 9 from here, minus 24 from here and 18 from here. Here we have a negative sign. The first element will be 9, minus of minus becomes plus. Plus 24, here we have 18. The sign is plus. Plus 18. To get the next element, here we have 0, minus 12, then here it is minus 8, minus 8. To get the next element, we have 20 from the first a square matrix. Then minus of minus becomes plus 38. Here we have minus 4. Plus minus 4 is minus 4. Next element 1 minus 20. Then plus 2. Plus 2. That is equal to 9 plus 24. What is 9 plus 24? We get 33. 33 plus 18, which is 51. Next, 0 minus 12 minus 8. Minus 12 minus 8 is minus 20. Minus 20. Next, 20 plus 38, which is 58. 58 minus 4 is 54. Next, 1 minus 20 is minus 19. Minus 19 plus 2. Minus 19 plus 2 is minus 17. So, these are the elements of a square minus 2ab plus b square. Understood? Separately we can find a square, 2ab and b square, then equate it to get the value of a square minus 2ab plus b square. Clear? Example 5, this is a question which was asked for 2019 board exam. Given 4, 2 minus 1, 1 into matrix M is equal to 6i, where I is the identity matrix. M is a matrix and I is unit matrix of order 2 by 2. State the order of matrix M. Second question, find the matrix M. First question, we are asked to find the order of matrix M. Here, the first matrix is 4, 2 minus 1, 1. And we are multiplying with the matrix M to get an identity matrix into a scalar 6, given that identity matrix is of order 2 by 2. So, this also will be a 2 by 2 matrix. Okay. So, multiplying a 2 by 2 matrix with another matrix gives a 2 by 2 matrix. We know that M by N matrix into N by P matrix will give us M by P matrix. First, we have to check if the number of columns from the first matrix and the number of rows in the second matrix are equal. Here it is already given that multiplying these two matrices we get a new matrix of order 2 by 2. If this is of order 2 by 2, then what should be the order of the matrix with which the multiplication is done? That is the matrix M. Here M is 2, N is 2. Then here again we have an N that will be equal to 2. Now P. This is what P is, M by P. M by P. We have P here. P is also 2. Therefore, the new matrix will be of order 2 by 2. A 2 by 2 matrix multiplied with another 2 by 2 matrix, we are getting a 2 by 2 matrix. Okay. This is the first part of the question. Now, the second part we have to find the matrix M. Let us consider a matrix M with elements with some variables A, B, C, D. We are going to find the values of this A, B, C, D. Then we can get the matrix M. Okay. Let matrix M is equal to A, B, C, D. Now we will perform the multiplication. Here we have first matrix 4, 2 minus 1, 1 into matrix M. A, B, C, D is equal to 6 into identity matrix. What are the elements of identity matrix? 1, 0, 0, 1. This is a 2 by 2 identity matrix. Now, we will multiply these two matrices. Here, the first row and the first column from the second matrix. What do we get? 4A, 2 into C plus 2C. Next element, first row and the second column. Here the first element of first row is 4. First element of the second column is B. 4 into B. 4B plus second elements from the first row and the second column we will be getting 2 into D. 2D. Now the third we have to take the second row and the first column. Minus 1 into A is minus A. 1 into C is C plus C. Next, second row and the second column. What do we get? Minus 1 into B is minus B. 1 into D is D plus D is equal to 6 into the identity matrix. Multiply each element with 6. What do we get then? 6 into 1, 6. 6 into 0, 0. 6 into 0, 0. 6 into 1, 6. Okay. Now we can equate them. First elements from this matrix and this matrix. What do we get? They are equal because these two matrices are equal. Therefore, the first elements, the corresponding elements should be equal. 4A plus 2C is equal to 6. Then the second elements, 4B plus 2D. This is the second element from this matrix. Here the second element is 0. Will be equal to 0. Now third, minus A plus C. What is this equal to? This is equal to the third element in this matrix, which is 0. Now the fourth, here we have minus B plus D. In the same position we have 6. Okay. Now when you consider these two equations, we have A and C in the first equation. Even in this equation we have A and C. These are linear equations in two variables. We can solve them to get the values of A and C. Similarly, when you consider these two equations, here we have in the first equation B and D, here also we have B and D. We can equate them, we can solve these linear equations in two variables to get the values of B and D. First, let us take this part. We have 4a plus 2c is equal to 6. The second equation is minus a plus c is equal to 0. Minus a plus c is equal to 0, which means we can write c is equal to a. Taking this minus a to the opposite side becomes plus a. C is equal to a. Now we are going to substitute this value of c in the first equation, that is 4a plus 2c is equal to 6. What do we get? 4a plus 2 into c becomes 2 into a is equal to 6. 4a plus 2a is 6a. 6a is equal to 6, which means a is equal to 6 by 6, that is equal to 1. 6 by 6 is 1. If a is equal to 1, then what is c? C also will be equal to 1 because a and c are equal. Now we will be finding what b and d are. We have 4b plus 2d is equal to 0. From this, minus b plus d is equal to 6, we can write d is equal to 6 plus b. Yes, d will be equal to 6 plus b. In the first equation, we are going to substitute d is equal to 6 plus b. What do we get? 4b plus 2 into 6 plus b is equal to 0. That is 4b plus, removing the brackets and multiplying, we get 2 into 6, 12 plus 2 into b, 2b is equal to 0. That is 4b plus 2b. 4b plus 2b is 6b. 6b plus 12 is equal to 0. 6b plus 12 is equal to 0. Taking this 12 to the opposite side, 6b will be equal to minus 12 and b is equal to minus 12 by 6, that is minus 2. We got the value of b. We had d is equal to 6 plus b. Now adding this value of b to 6, we will be getting what d is. D is equal to 6 plus b is minus 2, plus minus 2, which is 6 minus 2. That is 6 minus 2, 4. We got the value of d. We know a, b, c and d. Here we have a is equal to 1. We had matrix M is equal to a, b, c, d. Substituting the values of a, b, c and d, we get what the matrix elements M are. A is 1, b is minus 2, c is 1 and d is 4. This is the required matrix M. Clear? So if you have to find a matrix, in that case, you know it is a 2 by 2 matrix. We have to take the elements as A, B, C, D. If it is a 2 by 1 matrix, we can take A, B. Depending on the number of elements, we can add some variables to find the values of that variables to get matrix M. Okay? Let us solve problems from exercise 9C. Here is the first problem. Problem 1, question 3, exercise 9C. If A is equal to 3x01 and B is equal to 9, 16, 0 minus 5, find x and y when A square is equal to B. How to find A square? What is A square? When you have two numbers, let us take 2. 2 into 2 is 2 square. Then what about A square? A square will be matrix A into matrix A. Yes, here we have A is equal to 3x01. Then what is A square? A square will be equal to 3x01 into 3x01. That is A square is equal to. Now multiply. Here first row elements into first column elements. 3 into 3. 3 into 3 is 9 plus x into 0 is 0. Now the second element, first row and the second column, that is 3 into x is 3x plus x into 1 is x. Okay. Now the third element, second row and the first column, 0 into 3 is 0, 1 into 0 is 0, 0 plus 0. Now the fourth element, second row and the second column, 0 into x is 0, 1 into 1 is 1 plus 1. Okay. Therefore, a square is equal to 9 plus 0, 9, 3x plus x is 4x, here 0, 0 plus 1 is 1. We got a square. Given that a square is equal to b, which means we will be having 9, 4x, 0, 1. A square is equal to, b is 9, 16, 0, minus 5. 9, 16, 0, minus 5. These two matrices are equal. When they are equal, the corresponding elements should also be equal. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. Therefore, they are equal. Now, take the second elements. We have 4x is equal to 16, which means x is equal to 16 divided by 4. Then what is x? X is equal to 16 by 4, 4. We got x is equal to 4. Now, to find y, take the fourth element, 1 is equal to minus y. If 1 is equal to minus y, then y is equal to minus 1. We got x 4 and y minus 1. Clear? So, here to find a square, we need to multiply the matrix A into A. Okay. Next, problem 2, question 6 of exercise 9C. If A is equal to 0, 4, 6, 3, 0, minus 1 and B is equal to 0, 1, minus 1, 2, minus 5, minus 6, is the following possible? That is, first one AB, second BA and the third A square. When do we say that matrix multiplication is possible? If you have two matrices A and B. The number of columns of the first matrix should be equal to the number of rows of the second matrix. We used to represent, if you take an m by n matrix, then the second matrix should be an n by p matrix, which means this n represents the number of columns in the first matrix and that is equal to the number of rows in the second matrix. Only then you will be getting a new matrix which has an order m by p. Here first thing we have to find if AB is possible. AB means matrix A into matrix B. We know that matrix A into matrix B is not equal to matrix B into matrix A. They are not commutative. Matrix multiplication is not commutative. First, let us check if AB is possible. Here, what is matrix A? Order of matrix A? We have 2 rows. That is, M is 2 into number of columns 1, 2, 3. This is a 2 by 3 matrix. Okay. Now, what about B? Here we have 3 rows. 3 rows by number of columns, 2 columns. To check if AB is possible, we have 3 columns here and 3 rows here, which means AB is possible, right? Number of columns in the first matrix is equal to the number of rows in the second matrix. Therefore, first question, yes. Now, the second one. To check for the second one, B into A. B is a 3 by 2 matrix and A is a 2 by 3 matrix. Here again, what is the number of rows in the first matrix? Here B is the first matrix. Number of rows is 3. Number of columns in the first matrix, that is 2. Number of columns in the first matrix should be equal to the number of rows in the second matrix. Here we have 2 columns in the first matrix. Considering B as the first matrix, we need BA. When you are multiplying B and A, B will come first, then comes A. Number of columns in B is 2 and the number of rows in A is equal to 2. 2 and 2. Which means here again the matrix multiplication is possible. Yes. Now the third one. We have to find if A square is possible. How to check if A square is possible? A is a 2 by 3 matrix. Okay. We are multiplying this A again with A. That is also a 2 by 3 matrix. We are multiplying the same matrix. 2 by 3 matrix into 2 by 3 matrix. What happens here in the first part? A into A. Here the number of columns is equal to 1, 2, 3. 3 columns. Here in the second matrix again is A. A, we have the number of rows is equal to 2. Are they equal? Number of columns in first matrix and number of rows in second matrix. They are not equal, which means the multiplication of A into A is not possible. No. So first and second are possible. Third, it is not possible because here we are not getting the number of columns in first matrix equal to the number of rows in the second matrix. Understood? Next, problem 3, question 8 of exercise 9C. If M is equal to 1, 2, 2, 1 and I is a unit matrix of the same order as that of M, show that M square is equal to 2M plus 3I. Okay. Here in the LHS we should get M square, RHS we have 2M plus 3I. We will find M square separately and 2M plus 3I separately. We should show that these two are equal. How to find M square? We have matrix M is equal to 1, 2, 2, 1. Then what is M square? M square is M into M. M square is equal to 1, 2, 2, 1 into 1, 2, 2, 1. We know how to multiply matrices. The first element will be here this row into this column. 1 into 1, 1 plus 2 into 2, 4. This is the first element. Next, to get the second element, multiply this row, first row from the first matrix and second column of the second matrix. 1 into 2, 2, 2 into 1, 2, 2 plus 2, 2 plus 2. To get the third element, second row from the first matrix into first column from the second matrix, that is 2 into 1 plus 1 into 2, that is again 2 plus 2. Now the second row and the second column will give us the fourth element. 2 into 2 is 4, 1 into 1, 1 plus 1, that is equal to 1 plus 4, 5, 2 plus 2, 4, 2 plus 2 again 4, 4 plus 1, 5. 5, 4, 4, 5. We got M square, that is left hand side. Now let's find right hand side. Right hand side we have 2M plus 3I, that is equal to 2 into M. M is 1, 2, 2, 1 plus 3 into I. What is I? Unit matrix I. Diagonal elements 1 and the non-diagonal elements 0 containing diagonal matrix is what unit matrix is. That is equal to multiplying the scalars with the matrix, we get 2, 2 into 2, 4, again 2 into 2, 4, 2 into 1, 2 plus 3 into 1, 0, 0, 1, 3, 0, 0, 3. Now adding them, 2 plus 3, 5, 4 plus 0, 4, 4 plus 0, 4, 2 plus 3 again 5. 5, 4, 4, 5. Here again we have 5, 4, 4, 5, which means M square is equal to 2M plus 3I. We proved that LHS and RHS matrices are equal. Clear? Problem 4, question 12 of exercise 9C. Find the matrix A if B matrix 2, 1, 0, 1 and B square is equal to B plus half A. Okay, matrix B is given, we need to find what matrix A is. Okay, given that B square is equal to B plus half A. First let's find what B square is. How to find B square? Matrix B into matrix B. B is 2, 1, 0, 1 into 2, 1, 0, 1. Multiplying the same matrix, we will be getting 2 into 2, 4 plus 1 into 0, 0. To get the second element, multiplying the first row and the second column. 2 into 1, 2, 1 into 1, 1 plus 1. To get the third element, multiplying the second row from the first matrix and the first column from the second matrix. 0 into 2 is 0, 0 into 1 is 0. So, this is 0 plus 0. To get the fourth element, second row from the first matrix and second column from the second matrix. 0 into 1 is 0, 1 into 1, 1. That is equal to 4 plus 0, 4, 2 plus 1, 3, 0 plus 0, 0, 0 plus 1, 1. Okay, this is what b square is. Given that b square is equal to b plus half a. We'll put b square as 4, 3, 0, 1. B square is equal to b plus half a. B is 2, 1, 0, 1 plus half into a. Now we can easily find a, right? Half a is equal to 4, 3, 0, 1. Taking this matrix to the opposite side, it becomes minus. Minus this matrix 2, 1, 0, 1. Now subtract them. Half a will be equal to, we'll get a 2 by 2 matrix. We are subtracting 2 by 2 matrix from a 2 by 2 matrix. 4 minus 2 is 2, 3 minus 1 is again 2, 0 minus 0 is 0, 1 minus 1, 0. 2, 2, 0, 0. Now what is a then? A will be equal to, here it is 1 by 2. We are multiplying 1 by 2, which means we are going to divide with 1 by 2. This 2 can be taken to the opposite side. Here it is 1 by 2, division, a by 2. This becomes multiplication. 2 into 2, 2, 0, 0. That is equal to, multiplying the matrix element with 2, we get 4, 4, 0, 0. This is what the matrix A is. Matrix A is equal to 4, 4, 0, 0. Got it? Understood everybody? A is equal to 4, 4, 0, 0. Next, problem 5, question 14 of exercise 9C. If A is equal to 2, 1, 0, 0, B is equal to 2, 3, 4, 1 and C is equal to 1, 4, 0, 2, then show that first question A into B plus C is equal to AB plus AC. Second, B minus A into C is equal to BC minus AC. Here we need to find LHS and RHS separately and show that they are equal. In the first question, we have LHS A into B plus C. First we will find what B plus C is. Here B is 2, 3, 4, 1 and C is 1, 4, 0, 2. Then what is B plus C? Adding the elements of B with the elements of C. 2 plus 1, 3, 3 plus 4, 7, 4 plus 0, 4, 1 plus 2, 3. Okay, this is B plus C. Now we need to find A into B plus C. That is matrix A into matrix B plus C. B plus C we know 3, 7, 4, 3. What is A? A is given in the question 2, 1, 0, 0. Okay, we will be getting A into B plus C when matrix A is multiplied with matrix B plus C. Let us multiply. Here to get the first element we have first row from the first matrix 2, 1 multiplied with 3, 4, the first column of the second matrix, that is equal to 2 into 3, 6, 6 plus 1 into 4 is 4, 6 plus 4, 10. Now the second element, first row and the second column, 2 into 7, 14 plus 1 into 3, 3. We get 17. 14 plus 3 is 17. Next, 0 into 3 plus 0 into 4, that is 0. Next, again 0 into 7 plus 0 into 3 is 0. We got A into B plus C is equal to 10, 17, 0, 0. Next, we need to find AB plus AC. RHS is AB plus AC. Separately, we need to find AB and AC. AB will be equal to matrix A into matrix B. What is matrix A? A is 2, 1, 0, 0 and B is 2, 3, 4, 1. Okay, multiplying A and B. 2 into 2, 4 plus 1 into 4, 4. That is 4 plus 4, 8. Next, to get the second element, 2 into 3 is 6, 1 into 1, 1. 6 plus 1, 7. 0 into 2, 0. 0 into 4, 0. That is 0. 0 into 3, 0. 0 into 1, 0. Again 0. 8, 7, 0, 0. Next, to find AC. AC will be equal to matrix A 2, 1, 0, 0 into matrix C 1, 4, 0, 2. 1, 4, 0, 2. That is equal to, multiplying the elements, 2 into 1, 2. 1 into 0, 0. We get 2 here. 2 into 4, 8. 1 into 2, 2. 8 plus 2, 10. Next, 0 into 1 and 0 into 0, that is 0. Again 0 into 4, 0 into 2, that is also 0. We got 2, 10, 0, 0. Now to get AB plus AC, we'll add matrix AB and matrix AC. That is 8, 7, 0, 0 plus 2, 10, 0, 0. 8 plus 2, 10. 7 plus 10, 17. 0 plus 0, 0. 0 plus 0, 0. So, this is the required AB plus AC matrix. Okay. What is A into B plus C? A into B plus C is 10, 17, 0, 0. We got AB plus AC is equal to 10, 17, 0, 0. Therefore, A into B plus C is equal to AB plus AC. Hence proved. Now, the second part, here we have B minus A into C is equal to BC minus AC. First, we will find what B minus A into C is and check if BC minus AC is equal to this. Okay, here A is 2, 1, 0, 0, B is 2, 3, 4, 1 and C is 1, 4, 0, 2. First, let us find B minus A. Second one, B minus A. What is B minus A? Matrix B. Matrix B is 2, 3, 4, 1. What about A? What is A? Here we have A equal to 2, 1, 0, 0. Subtract these. What do we get? B minus A is equal to first elements. Here it is 2. Here again it is 2. 2 minus 2, 0. Next, second elements. Here we have 3 and here we have 1. 3 minus 1, that is 2. Third element, here we have 4 and here it is 0. 4 minus 0, which is 4. And the fourth element, 1 minus 0, 1. We got B minus A. What else is there? We have to find B minus A into C. B minus A into C. We got B minus A, that is 0, 2, 4, 1. What is C? Here we have C in the question, that is 1, 4, 0, 2. Now perform the matrix multiplication. First row, first column. What do we get? First row, first column. First element 0 into 1, that is 0. Then 2 into 0, 0. That is, here we get 0 plus 0. Next, first row, second column. To get the second element, here we have 0, here we have 4, which means 0 into 4, 0. Next, 2 into 2, that is 4, plus 4. Third element, second row, first column, 4 into 1, 4, plus 1 into 0, 0, 4 plus 0. Next element, second row, second column, 4 into 4, 16, plus 1 into 2, 2. So adding this, we get the elements of matrix B minus A into C. What are the elements of B minus A into C? Is equal to 0 plus 0, 0, then 0 plus 4, 4, next 4 plus 0, 4, 16 plus 2, 18. We got the elements of B minus A into C. Next we have to find BC minus AC. First let us find BC. BC is equal to matrix B into matrix C. What is matrix B? 2, 3, 4, 1. 2, 3, 4, 1. Matrix C 1, 4, 0, 2. 1, 4, 0, 2. Multiplying first element, first row, first column. 2 into 1, 2 plus 3 into 0, 0. Here we get 2. Next element, first row, second column. 2 into 4, 2 into 4, 8 plus 3 into 2, 6. That is 14. 8 plus 6, 14. Next element, second row, first column. 4 into 1, 4. 1 into 0, 0. 4 plus 0 is 4. Next element, second row, second column. 4 into 4. 4 into 4, 16. 2 into 1, 2. 16 plus 2, 18. So these are the elements of product of B and C, matrix B and matrix C. Next, similarly, we have to find AC, A into C. A into C. For that, you have to take matrix A and matrix C. Elements of matrix A are 2, 1, 0, 0. Next, elements of matrix C. What are the elements of matrix C? 1, 4, 0, 2. 1, 4, 0, 2. Then what do we get? AC is equal to, multiplying, you will get the elements. First row, first column. 2 into 1, 2. 1 into 0, 0. 2 plus 0 is 2. Next, first row, second column. 2 into 4, 8 plus 2 into 1, 2. 8 plus 2, 10. Next element, second row, first column. 0 into 1, 0. 0 into 0, 0. 0 plus 0 is 0. Next element, second row, second column. 0 into 4 is 0. 0 into 2 is again 0. 0 plus 0, we get 0. Now we have to find what BC minus AC is. BC minus AC. We have BC. What is BC? 2, 14, 4, 18. Minus AC. 2, 10, 0, 0. Then what are the elements of BC minus AC? Subtracting AC from BC. 2 minus 2, that is 0. 14 minus 10, 4. 4 minus 0, 4. 18 minus 0, 18. Okay, these are the elements of BC minus AC. Now we have B minus A into C, that is again 0, 4, 4, 18. Here also we have 0, 4, 4, 18, which means B minus A into C is equal to BC minus AC. From this we can conclude that matrix multiplication is distributive under addition and subtraction. From the first sub-question we got that A into B plus C, distribution, removing brackets and distributing, AB plus AC. Second question, it is subtraction, B minus A into C. We got BC, B into C minus A into C. Got it? So, we are proving the distributive property for multiplication of matrices here. We have associative, commutative and the distributive property. We got it is not commutative but associative. Matrix multiplication is associative. Now, we got the matrix multiplication is distributive. Okay. Next, problem 6, question 18 of exercise 9C. If A is equal to 2x01 and B is equal to 43601, find the value of x given that A square is equal to B. Here we have to find A square first. Matrix A is equal to 2x 0 1. What is A square? Matrix A into matrix A. That is 2x 0 1 into 2x 0 1. Is the matrix multiplication possible here? This is a 2 by 2 matrix. 2 rows, 2 columns. What about this? This is the same matrix. 2 by 2 matrix. Then on multiplying this, here the number of columns in the first matrix and the number of rows in the second matrix are equal. We will be getting a new matrix whose order is 2 by 2. Now we need to find the elements of these 2 by 2 matrix. 2 into 2, first row and the first column. 2 into 2, we get 4. 4 plus 0 into x, that is 0. 4 plus 0. To get the second element, we have to consider the first row of the first matrix and the second column of the second matrix. 2 into x, 2x plus x into 1 is x, 2x plus x. Now to get the third element, we have to consider the second row of first matrix and the first column of second matrix. 0 into 2 is 0, 1 into 0 is 0, 0 plus 0. Next element, we have to consider the second row of first matrix and the second column of second matrix. 0 into x is 0, 1 into 1, 1. Adding these, we will be getting the required 2 by 2 matrix, that is A square. A square is equal to 4 plus 0, 4, 2x plus x is 3x, 0 plus 0, 0, 0 plus 1, 1. We got the elements of A square. What else do we need? A square is equal to B. We just need to equate this A square with B. A square is 4, 3x, 0, 1. That is equal to 4, 36, 0, 1. From this we can find the value of x. Here all these elements are equal. 0, 0, 1, 1. Now the second element from both the matrices, we can equate them and find the value of x. 3x will be equal to 36. Yes, if 3x is equal to 36, what is x? X will be equal to 36 divided by 3, which is 12. The value of x is equal to 12. Very easy, right? We just need to find A square first. After getting A square, equating with B, we get the value of x. Okay. Next problem. Question 26 of exercise 9C. If A is equal to 4, 2, 1, 1, find A minus 2i into A minus 3i. What is I? Should I repeat? We know, right? What is I? I is the unit matrix or the identity matrix. Elements of I. Here I is a 2 by 2 matrix. Elements will be 1, 0, 0, 1. We have A is equal to 4, 2, 1, 1. Okay. We know identity matrix I is equal to 1, 0, 0, 1. Now we need to first find A minus 2i and A minus 3i. What is A minus 2i? A minus 2i is equal to matrix A minus I into 2. That is 4, 2, 1, 1 minus scalar quantity 2 into identity matrix 1, 0, 0, 1. That is equal to 4, 2, 1, 1 minus 2 into 1, 0, 0, 1 is equal to multiplying each element of the matrix with 2. We get 2, 0, 0, 2 into 1, 2. Now subtracting, we get what A minus 2i is. A minus 2i is equal to matrix 4 minus 2. What is 4 minus 2? 2. 2. Then second elements. Here we have 2 and here we have 0. 2 minus 0, that is again 2. 1 minus 0. Third elements. 1 minus 0 is 1. then 1 minus 2, which is minus 1. We got a minus 2i. Similarly, we are going to find a minus 3i. A minus 3i is equal to, we have a 4, 2, 1, 1 minus 3 into identity matrix 1, 0, 0, 1. That is equal to 4, 2, 1, 1 minus multiplying each elements of the identity matrix with 3. What do we get? 3 into 1, 3, 3 into 0, 0, again 3 into 0, 0, 3 into 1, 3. That is equal to, subtracting this matrix from this first elements. Here we have 4 and here we have 3. 4 minus 3, which is 1, 2 minus 0, 2, 1 minus 0, 1 and 1 minus 3. What is 1 minus 3? Minus 2. These are the elements of a minus 3i. We got a minus 2i and a minus 3i. Now we will find a minus 2i into a minus 3i. That is equal to, first matrix 2, 2, 1 minus 1. 2, 2, 1 minus 1 into second matrix a minus 3i, that is 1, 2, 1 minus 2. Now the normal matrix multiplication can be performed. This is a 2 by 2 matrix, this is a 2 by 2 matrix. That is equal to, we need to find the elements, we will be getting a 2 by 2 matrix. Yes, here the number of columns in the first matrix is equal to the number of rows in the second matrix, which means the number of rows in by the number of columns will be the order of the new matrix. First row and the first column, here we have 2 and 1, 2 into 1, 2, 2 into 1, 2, plus 2. To get the second element, we have to consider the first row and the second column. 2 into 2, 4, then 2 into minus 2, which is minus 4. To get the third element, we have to take the second row of first matrix and the first column of second matrix. 1 into 1, 1, minus 1 into 1, minus 1, minus 1. To get the fourth element, we have to take the second row and second column. 1 into 2, 2, minus 1 into minus 2, which is plus 2. That is a minus 2i into a minus 3i is equal to, adding the elements, 2 plus 2, 4, then 4 minus 4 is 0, here again 1 minus 1 is 0, then 2 plus 2, 4. 4, 0, 0, 4 are the elements of a minus 2i into a minus 3i. Okay. Here we have the last problem for today. Question 29 of exercise 9c. If P is equal to 2, 6, 3, 9 and Q is equal to 3x, y, 2, find x and y such that PQ is equal to null matrix. What is null matrix? In the first class we have discussed what null matrix is. What was null matrix? Null matrix, a matrix with all the elements equal to 0 is called a 0 matrix or a null matrix. We represent it with the letter O. The elements are 0, 0, 0, 0. This is a 2 by 2 null matrix. If it is a 3 by 3 null matrix, we will be having 0, 0, 0, 0, 0, 0, 0, 0, 0. Now here we have P is equal to 2, 6, 3, 9 and Q is equal to 3x, y, 2. We are given that PQ is equal to null matrix. We will find what PQ is. PQ is equal to matrix P into matrix Q. P is a 2 by 2 matrix with elements 2, 6, 3, 9. What about Q? What is the order of Q? Q is also a 2 by 2 matrix. We can find that here we have 2 rows and 2 columns. Elements are 3, x, y, 2. Now we will perform the multiplication. Considering the first row of the first matrix and the first column of the second matrix. What do we get? PQ is equal to get the first element. Here we have 2 into 3, that is the first element of first row and the first element of the first column of second matrix. 2 into 3 plus second element of first row of the first matrix, second element of the first column of the second matrix. 6 into y, 6y. Okay. To get the second element, we have to consider the first row and the second column. This is the second column of the second matrix. Here we have 2 into x, the first element of first row and the first element of the second column. We get 2x plus second element of the first row, second element of the second column. 6 into 2 is 12. Okay. Now, to get the third element of the product matrix, we have to consider the second row of the first matrix and the first column of second matrix. First element, here we have 3 and here also we have 3. 3 into 3, that is 9 plus second element of the second row and the second element of the first column. To get the third element, we have to take the second row of first matrix and the first column of the second matrix. 3 into 3. 3 into 3 is 9 plus second elements 9 and y. 9 into y is 9y plus 9y. To get the fourth element, we will consider the second row of the first matrix and the second column of second matrix. Here the first elements are 3 and x. 3x. Then 9 and 2. 9 into 2, 18 plus 18. Okay. That is matrix elements of PQ is equal to 2 into 3, 6 plus 6y, 2x plus 12, then 9 plus 9y and 3x plus 18. Given this is equal to null matrix, which means 6 plus 6y, 2x plus 12, 9 plus 9y, 3x plus 18 is equal to 0, 0, 0, 0. Now we can easily find the values of x and y. We know we have solved many similar questions. Yes? Considering the first elements, here we have 6 plus 6y is equal to 0. From this we can find the value of y. What is 6y? 6y will be equal to, taking the 6 to the opposite side, it becomes minus 6. And y is equal to minus 6 by 6, which is minus 1. Now to get x, either we can take this element or this element. Both contains a variable x. Here I am taking 2x plus 12. 2x plus 12 will be equal to 0. This is the second element of the second null matrix. 2x plus 12 is equal to 0. 2x is equal to, taking 12 to the opposite side, it becomes minus 12. And x is equal to minus 12 by 2, which is minus 6. We got the value of x and y. X is equal to minus 6 and y is equal to minus 2. Understood? That's all for today. In today's class, we have studied matrix multiplication with examples and solved many questions from exercise 9C. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai पर बेस्ट है. थैंक यू.